Today we're going to be looking at proportional relationships with tables. A coffee shop displays their prices on a chalkboard menu. The prices are proportional, but some of the information got erased. Part A. What is the constant of proportionality? Now, the constant of proportionality, as we all know, is K equals Y over X. So we need to take a look at our table. Remember, X values are on the left side and Y values are going to be on the right side. So we have to pick an ordered pair and just simply divide it. I'm going to go for the easiest one here, and I'm going to do 5.50 divided by 2. And if I divide those two, I get 2.75, or 2 and 75 hundredths. Part B. How can you use the value of K to find the missing prices on the menu? Use this method to complete the table. Well, I know that when I had to find my constant of proportionality, I had to divide. And since I have all of my X values, I just have to multiply. So I'm going to multiply with cups of coffee. So to fill out the first one, 1 cup of coffee is going to be $2.75. And then 3 cups of coffee, so I would just do 2.75 times 3, and I would get $8.25. Part C. How does the total cost change as the cups of coffee increase by 1? Well, since our constant of proportionality is 2.75, it increases by 2.75. Rate of change. The rate of change describes how one quantity changes. It could be an increase or decrease in relation to the other quantity. In a proportional relationship, the rate of change is equal to the constant of proportionality, or K. All right, in 1 through 2, we have our equation, and we have to use it to fill in our table. So remember, the X in our equation represents the X values, and then the Y in the equation represents the Y values. So we're going to do Y equals 9.5. Instead of X, we're going to substitute in 0. Anything times 0 is going to be 0. So we're going to follow that same process to fill in the rest of the table. Next one is Y equals 9.5 times 1, which gives us 9.5. And the next one is Y equals 9.5 times 2. So that gives us 19. And the last one is Y equals 9.5 times 3, which gives us 28.5. Now the rate of change, what did we increase by each and every time? Well, we increased by 9.5, or 9 5/10. Number 2, as the X values increase by 2, that kind of seems like I should underline that. The Y values increase by 60. So I'm going to look at my table here, and I'm going to go to where it says X is 2. And it says as the X values increase by 2, the Y values increase by 60. So I'm going to put a 60 right there. And I'm going to think to myself, K equals Y over X. So I'm going to do 60 over 2, which equals 30. So that tells me the rate of change, or constant of proportionality, is 30. So when X is 1, Y should be 30. And now I'm going to think to myself, 30 times 3 is 90. And then that last value should be 120. So the rate of change, 30. Number 3, Camping Craze hires a graphic designer to create a new logo and marketing materials. The graphic designer charges Camping Craze $45 per hour. Complete the table and then answer questions A through C. So I'm going to start with the table. Remember, X values are on the left side, Y values are on the right side. So I'm going to do 0, 1, 2, 3, and 4. So I'm going to think to myself, if the person only worked 0 hours, they're not going to charge anything because that means they haven't started yet. But then if they work 1 hour, they're going to charge $45. And then if they work 2 hours, they would charge $90. If they worked 3, they're going to charge $135. And then if they worked 4 hours, they're going to charge, I should say, $180. So it's increasing by $45 each hour, which leads us to part A. Part A says to find the rate of change. Well, it's 45. That's what the graphic designer charged. So what does the rate of change represent in the context of the situation? The rate of change is 45, so that's the charge per hour. Part C, write an equation to show the relationship between X, the number of hours, and Y, the total charge of the graphic designer. Remember, the equation is Y equals KX. And the rate of change in this case is 45, so it's going to be Y equals 45X. Okay, we're not going to do number 4. We are going to do number 5. Number 5 says gasoline is priced at $3.39 per gallon. Write an equation to represent the total cost Y of purchasing X number of gallons. Well, remember, our equation is Y equals KX. So when you're finding gas, you're multiplying, or finding the cost of gas, I should say, in total, you're going to multiply the price per gallon by how many gallons you put in your car. So it's just going to be Y equals 3.39X. Okay, we are not going to do number 6. We're going to skip to number 7. Number 7 says Michelle reads a book for the school readathon. The table shows the proportional relationship between X, the number of minutes, and Y, the total number of pages read. Part A, determine the rate of change and explain its meaning in the context of the situation. So looking at our table, remember, X values are on the left side and Y values are on the right side. So to find the rate of change, we have to find the constant of proportionality. K equals Y over X. So we're just going to use the first set, our first order pair in this table. So it's going to be 15 over 30. And I can simplify that. I could divide both numbers by 15, and I would get 1 over 2. So Y represents the total pages read, and then X represents the number of minutes. So what that means is she read 1 page in 2 minutes. And I'm going to abbreviate minutes. Part B, write an equation to represent the total number of pages as it relates to the number of minutes read. So our rate of change is 1/2. It's going to be Y equals 1/2 X. It could also be Y equals 5/10 X. Either one's going to be correct. Okay, we're not going to do number 8. We are going to do number 9. Number 9, it says Sue traveled by car at a constant rate. After 4 hours, she had traveled 272 miles. So that kind of seems important to know. It says circle any of the following that represent the relationship between the distance traveled and the hours driving. Well, first I need to determine what my constant of proportionality is, which is my rate of change. So I'm going to always do time on the bottom. That's our independent variable. So 4 would go on the bottom of my rate, and then 272 would go on the top. And if I divide those two, I get 68. I just kind of need something to start with here. So for A, it has a horizontal table. So the X values are hours and the Y values are miles. I need to divide to determine if it equals 68. So I have to do 540. I'm going to write just a little bit smaller here, make my pen smaller. 340 divided by 5. All right, so it doesn't go into 3, but it goes into 34 6 times without going over. I'm going to subtract 30 for a remainder of 4. Bring down that 0. It goes in 8 times. So yes, A could possibly be, or it is, one of our representations. B says D equals 272t, where D is the distance in miles and T is the time in hours. Well, our rate is not 272, it is 68, so B is not it. And then C says Sue is traveling 68 miles per hour. Well, that's correct because we just determined that Sue was traveling, her rate was 68. All right, good job solving problems that are proportional relationships with tables.